So let's very quickly review how this all fits together. We want to solve ax equals b. We factor a into L times u. We then substitute in L times u into the equation. We place our parentheses differently. We recognize that we can view u times x as some vector y. We don't know what that vector y is, but now we get the constraint that L times y has to be equal to b. We can then solve for y. Once we solve for y, we solve for x. We have an algorithm for computing the LU factorization. We have an algorithm for forward substitution or solving a lower triangular system. And we have an algorithm for solving an upper triangular system, which can also be viewed as back substitution. What are the remaining questions? What if we encounter a divide by zero? Notice that as you are performing your LU factorization, you are taking the current diagonal element and dividing it into the elements below it in order to compute the multipliers. And there's the potential there for dividing by zero. That would not be a good thing. As a matter of fact, if you start with matrix 0, 1, 1, 0, this would happen in the first step. If A is square, does ax equals b always, sometimes, or never have a solution? This is something we need to study. If a is not square, does it always, sometimes, or never have a solution? This is another thing that we're going to study. So, there are plenty of questions to be answered in the next few weeks.